we're back without Caleb. We're not happy. May's happy because she gets to be camera girl and make some money today, right? So show everyone your little handheld. Yep, she's a little short here in the screen, but you'll be able to see it. We are working on a few cars today. The first one is I believe, is this 2013, Danner? Something like that? Something like that, yeah. 2013-ish. We'll find out here in a minute. Chrysler Town and Country. It has some interesting history to it. Let me grab this piece of paper. I won't mention the dealership. They might be right in what they told them. But they brought it to the dealer and it says customer complaint was check engine light is on, the engine sputters. Engine sputters. Perform tests. It says needs O2 sensor and PCM. All right. So what does it need the O2 for? It says P0443 is the bank one, sensor one, O2 high voltage code. They're saying it needs an O2. It very well may need an O2 for that. And then the P0443 evap purge control circuit, it says they load test wiring equals okay, tried known good purge valve, same condition, internal in PCM, replace and reprogram. So they are saying that the purge control fault for this car is because of a faulty computer. Got it? And that would be for the computer and reprogram. Look at that number. Holy crap is right. $1,028 plus tax would be the estimated cost of the engine computer. And oh, they're also recommending a fuel induction service, which is $145. The O2 is $255. What'd you do?
I pinched myself really bad.
You dummy. So yeah, pretty substantial estimate here. What's the math real quick on that? 1,028, 255, 145, so
I'm not in school right now.
4. So it's about $1,500 plus tax for what they want. So that's where we're at. Let's scan it. Check the O2, check the purge valve, and you know, it also had a sputtering complaint, and we have a misfire code, which I did scan this real quick before we brought you guys in. But let me show you the scan tool, and let's continue. May is going to be camera woman today. Thanks for being here with me. And she enjoyed it last time. You guys enjoyed having her with us as well as I did.
You're sweaty.
I'm sweaty. Okay, let's get started. I'm just trying to move this air cleaner out of the way so I can get you guys a shot of this purge valve and the tests I want to do. We're going to start with that. I'll get you a shot of the scan tool. I realize I haven't shown you that yet. Just give me a second. I'm just trying to get set up and I'm missing my cameraman, which is kind of messing me up a little bit. So Caleb is on his honeymoon. Last video that you guys saw with May, Caleb was on his honeymoon right after his wedding. But due to COVID, they could only go to stay in state, and they went north to Lake Erie for a couple days. Now this is their real honeymoon. They're spending a week in South Carolina at Myrtle Beach. So yeah, we're missing Caleb again because of his honeymoon again. Purge valve is right there. I got that song stuck in my head. That freaking Bringing Home My Baby Bumblebee. All right, so I have us focused on the purge valve on that camera. That's this guy right here. Let me show you guys the screen. There's our codes. Multiple cylinder misfire, evap purge control, and then an O2 sensor 1-1 circuit fault. I will be running this engine with the air filter off. It's not a problem because this is a non-mass airflow engine. You know, we do need to look at the misfire code. I'm just going to start with the purge valve because they're saying it needs an engine computer for the purge valve. So first thing I'm going to do is go to my functional test menu and turn this purge valve on. We're going to listen to it. Purge vapor test. Let's do that one. Key on engine run. All right, it says engine must be running for this test, but the first thing I want to do before I run any test is see if I have voltage on this purge valve. Connecting my test lead to battery negative. Just going to volts DC on the scope. Nothing on that wire. Nothing on that wire. Seriously? I got no voltage on this purge valve. Let's make sure that my lead works. Always want to check your meter whenever you have some weird readings. You see I'm reading 12.3 volts. Back over to my purge. Nothing on that wire, nothing on that wire. I mean, unless that's a power side switch purge valve, I need to check a diagram. Be helpful to know that. Let me look at a wiring diagram real quick to see how this purge valve's controlled. Wouldn't that be funny if the purge valve and the oxygen sensor shared a power feed? I swear that this should have a feed on it. There's my purge solenoid. Okay. I know this is a zoomed out view. I'm struggling with my program right now. One wire, as you can see, goes to the engine computer. The other wire goes onto the next page, dark blue and white, next page again. I like this about the new Mitchell diagrams, how the colored highlighter carries on to the next pages. Dark blue and white. Okay, so this is power side switch circuit. Both wires do go to the engine computer, and one of them said return RTN, which would be the opposite wire that's highlighted right here on the screen. This one, see if I can zoom, if this lets me. It's like super delayed. I'm gonna snap. I can't. Dark blue and white should be my control signal. The blue and whatever trace, that should be the ground. Let me grab my test light, we'll prove that. Checking my test light, I'm connected to battery positive. When I find a ground, the light's gonna light, okay? So, the way that you can tell which of the two, let me unplug this first. I believe that this wire is my computer ground. Make sure we're making contact. Nope. On a typical power side switch circuit, you have a constant ground in the computer on the other wire, and so what this is telling me here is that I don't have a ground. Oh my goodness, look how spread apart that is too. That's bull. Let's see if we can show that. So some schmuck, I don't know, can you see the pins in there? Is that showing up on the camera?
I mean,
these are completely spread apart. Somebody stuffed their test leads in there. Yeah, they're freaking, that's ridiculous. And then they poked you see a poke mark in the wire too, which is, you know, it's fine. Seal it when you're done, but never do that. Why would you do that? You just ruined this connector. This connector's garbage. Garbage. A power side switch circuit, one of these two is gonna have a constant ground, and we do not have that. So that's not good. I want to check the computer's control signal, but I have to fix this terminal. Why would they do that? They legit destroyed this connector. So according to the diagram though, this white, blue with a white should be the computer's control signal. I'm going to start this up. We'll try to do that test. I'm going to switch my test light to battery ground. So when I touch power, it'll light. I have the solenoid unplugged, so we're just going to use the test light for this. I'm just going to back probe it, or put my pin back in there, maybe so we can see a scope pattern of it too. Touch my test light on there. When I run this test, that light should light if I hit flow, and it does. Block, flow, block. Not sure what normal does. So how is the control wire from the connector to the computer on that side? It's good, but the problem is we're missing a ground. I need to check that ground wire. Hopefully that test made sense. What I just showed, that was the power switched side of the circuit. We're missing a ground on the other side. I need to check that same wire from the connector all the way at the computer. So that's the next step coming up. Can you see the spread terminals? Can you see the spread terminals? Yeah. That's because the dealers teach their techs never back probe a connector. So what do? They stick their lead in the front side of it, spread the pins apart, create problems. Why? Because you don't want to back probe? Well, we substituted a known good purge valve, so it's got to be a bad computer, right? Come on. I mean, it might be a bad computer. These things have issues, but that is not troubleshooting. That's ridiculous. Cannot believe that that's a dealership technician job right there. Ridiculous. Yeah, sorry about that, guys. We had a mic shift here. I forgot to turn the main camera back on. May's using this one. Totally missing our cameraman. We have no idea what we're doing. It's the dark blue white we checked. That's the feed, the switched power. Pin 65. It's a dark blue and brown. All right, can I see this on this connector? A bunch of blacks. I think this is the right one. What did I say? Dark blue and brown? I believe it's that guy right there, because there's a blue white there too. Okay. Hold this. So I'm going to hook into this. That should be my guy. This probe is broken. Oh, I broke it. That sucks. I broke it. So right, can you see that wire that I'm pointing to? It's blue and white.
Yep.
And then right next to it's the dark blue and brown. Yeah. This should be my ground signal. I will put some liquid tape on this when I'm done. And we should have a ground. We should have a ground on that right there. Test light to battery positive, touch a ground, light should light. Down here, May, you can probably get this shot. Can you see that right there? It is not lighting. So it looks like they made the right call that that part of the computer is bad. It needs a computer, but it's just a constant ground. I'm just wondering if I can ground it myself and see if I can make this code go away. Make sure that we're on the right wire. I'll turn the key off. A couple ways we can do this. I can use the ohm meter, or I'll just use the voltmeter. Go to battery ground on that. All right, with my meter connected, we'll just go right to that computer ground wire. Blue with a brown. And then when I touch my test light on that down there, that voltmeter should move. Should go to 12 volts. I get this right. Can you see what I'm doing?
Yeah.
There we go. And test light is not lighting, of course, but that is the right wire. I could have done a resistance measurement. That was just an easier way to do it. This computer is faulty, Danner. Is it? Yeah. But it's the ground side, and the computer doesn't switch the ground side of this. It switches the power side. And I'm just thinking, depending on the monitor, I might be able to run a ground wire. Maybe. I mean, it's not right, but we're not done. I mean, we have a misfire still, and we have an O2 code still I got to look at. But
is it misfire?
Well, I have a misfire code, and the customer's complaint is shuttering.
Oh, okay. So no ground on the...
No ground. And then, of course, this needs a new connector, too. Because, I mean, is that ever going to work right again?
No.
No.
No. It'll set random codes.
Right. Intermittent purge valve faults. Oh, must be another bad engine computer.
I wonder if there's any other codes or any other circuits that are dead, or if it's just that one.
Yeah, I should probably, before I monkey around, I should probably check the O2 now. Let's do that. Let's just see why they said the upstream O2 was bad. Heater's working. See that bias came down real quick. circuit high code with the O2. Heater circuit's working fine. With the drop in voltage from, we started at 2.5 volts and then we dropped down. That indicates good heater circuit activity. Without even looking at the heater circuit, I'm telling you that it's working. This gives percentage of heater operation. Doesn't look like they give an amp draw like a Ford does. So probably the right call as far as the O2 goes. I believe this still only has one upstream O2. Maybe not. Let's see. No, this does have, sorry, this has two different upstream O2s. So we have an O2 code, O2 fault that's not here right now. And then we have a random misfire code too. These are known for coil issues. Of course, they're buried underneath the intake manifold. Let's go back. So intermittent misfire, or at least the codes, intermittent O2 fault, constant purge issue, ASD main sense circuit. That's a new code. I might have set that with my little test light test. Exit out of here. Let's clear them. I just cleared the codes. We want to reread them. And that's saying none present. Let me start it back up. It should definitely set a purge code. Purge control, cool. Now let's see, when I do this, my test light's a battery positive. See if that sets an ASD sense circuit fault. So we just had the key on. No, that was weird having that ASD sense code. Didn't like that. Unfortunately, I have to fix this before I can plug it in and try running a ground wire. Well, I'll tell you what, we could substitute the test light. Let's see if we can get rid of it. We'll go test light to ground, and then I'll back probe this. So basically I have a purge valve installed right now. I'm using my test light as the purge valve. So it'd be, computer would be feeding power on the blue-white wire. It would go into my test light pin through the bulb to battery ground, essentially simulating a purge valve, not grounded at the computer, but grounded at the battery. And what I'm doing here is, if I can make this code go away, then it is a viable option that you could run a ground wire to that. It does need an engine computer, for sure. Yeah, I can't get rid of that code. Why? Should be able to. That's going to battery ground. I was able to get rid of it before, unless I am not making contact. I mean, it's already been stuffed in there, so we'll just touch it on the front. Nope. How was I able to get rid of it before? Turn the key off and back on again. Should be able to get rid of this purge fault. I'm going to start this. That light should light. It's if I'm connected and that purge valve does what it's supposed to do. No codes. Can we, let's make sure that our purge vapor test works and flow that. Yep. So that driver works. Yeah, so that is not a monitored ground. We could run a ground wire on that and it would work. Get rid of the purge code. I'll tell you what, for $1,000, that's what I'd do if it was my car. It's just a monitor, it's just a ground that goes to the board and it's not monitored. How do I know it's not monitored? Because I have my test light acting as the circuit. I'm going to ground on the battery, and the computer likes what it sees. It is a viable option. So I need to fix that connector. Talk to Danner, we'll see what the customer wants to do. As far as the misfire goes though, that it has, we should probably, I mean, you can get a misfire from an O2 that fails. We're gonna shut down momentarily, and I need to set this up so we can test drive it. We gotta find out what's going on with that, so we can at least get this summed up for you guys. We'll be right back. All right, go ahead. Before we go for a test drive, I'm gonna straighten these pins out.
So how are you gonna straighten them out?
Well, I pulled this cover off. Then I'm gonna release this pin, pull it out from the back side.
Wow.
And then what we can do, we can bend this back. You see the difference between the one that I just did and the one up above it?
Yeah.
See how it's,
yeah.
See how it's closed up? So that's what I mean. Like, what you can't see on the other end of this connector is there's male pins. These are called female terminals. The one in my hand that'd be a male terminal, you know, for obvious reasons. And but what happens is somebody stuffed the test lead into the top of that and they spread it apart. And then it'll never fit the male terminals the way they're supposed to. So I just kind of bent it back. So look how butchered that is. Like, look how misshaped it is.
Yeah. So what did they stick in it to?
A test lead, a test light, trying to test the circuit. But they butchered it. Hey,
Yep.
a lot better looking, huh?
Mm-hmm. Why are you removing the tape?
Well, because I'm going to run a jumper wire to that probably, but I need to hear from Danner first. Yo, brother.
Yes, sir.
All right. So it definitely needs a computer. That wire's not open. I fixed the terminals, tightened those back up. We can run a jumper wire, and I can get rid of that code. I did an experiment with my test light as this purge valve, leaving the ground wire out of the mix and just having my test light into the control wire, which is power side switched, going directly to battery ground, and that code does not come back. So the ground side's not monitored.
Okay.
So we can run a ground wire to get rid of that, but I want to take this for a test drive because we have an O2 code that's working, the O2's working, and then we have a misfire code that none of that's been addressed. So I don't want to say, hey, let's wire that and then, you know, ship it. It probably does need an O2. They do fail. As far as the misfire goes, though, random misfire, I'm a little concerned about that. These are known for coils and plugs that go bad. My neighbor had one, and we did a bunch of them on his. So unfortunately, the intake covers the front three, and then this guy covers the. You can get to the back three, but not the front three.
Random misfire,
Random
not even
Correct.
cylinder specific.
So May and I are going to go for a test drive before we do anything else.
Okay.
I'm going to put that cover back on underneath because we're done under there. It does need a computer.
Okay.
And I just want to see what else we're dealing with.
Yeah, for sure.
So the wire that I poked into is this one right here. Can you see that?
Yeah, let me.
So sometimes this kind of stuff is out in the environment where it's harsh. And so it just coats the hole that I put in the wire when I did my test.
Oh.
That's all.
Cool.
Cool?
Cool.
All right, so we're gonna have a purge code when we drive this. We don't care right now. I wanna see what else this thing's doing. All right, we're gonna switch out batteries, okay? Then we're gonna go for a test drive.
Okay.
Gotta turn that off. All right, so May and I are going for a test drive. We have our evap purge control fault that is back because I didn't run any kind of jumper wire or anything yet. I'm not sure what we're doing, whether we're putting a computer in this or not. I want to make sure that the other components, the misfire code and then the O2 fault. So I want to try to hopefully recreate that. All right, we're just gonna test drive it.
Sorry, Caleb, this is gonna be shaky.
You can have it all. Yeah.
I got it.
You good?
Yeah.
You can extend that so you have it on the seat.
Yeah.
And then hold it. If I don't feel any misfires while I'm driving this, I'm not going to be overly concerned about a coil or a plug issue. We'll just have to leave that part of the repair open. It does need a computer for the purge valve.
I'm doing pretty well.
You think so?
Yes.
Yeah, customer complaint was a shutter was the what the repair order said. And an O2 fault can certainly give you a shutter. Definitely starting to see some issues with the Bank 1 sensor 1 as far as the frequency. Just comparing it to Bank 2 sensor 1, we got some gaps in there. O2 sensors will typically fail when they're hot. So far, you know, I did make fun of the dealer tech for his troubleshooting techniques and spreading those terminals apart. But so far, I think they were right in what they told her, which I think she needs he or she, whoever owns this car, needs an engine computer. We already know that. And then probably just needs an oxygen sensor with the code it had. And they tried to upsell them an induction service for maybe the stuttering issue. You know, induction services aren't a bad thing, but that's not what's causing our issues here. That's more of just a preventative maintenance. I don't think selling preventative maintenance stuff is a viable option whenever you have some unknowns. Maybe another one to think about is the purge valve itself. Some of you might be thinking, well, that purge valve could have shorted and taken that ground out. Well, you wouldn't be wrong, but I would challenge that it wouldn't be the ground circuit that it would take out. It would take out the switched power side. That's the side with the driver. So I'm not overly concerned about the purge valve. I mean, we can double check it. But I also feel no misfiring at all. And I'm not seeing an O2 fault at this point. So Bank 1 sensor 1 O2, you know, sometimes being a parts changer is okay. Especially when you've done at least some preliminary checks. I wouldn't be in a rush to change an O2 just on a code, but the fact that I know the heater circuit's working properly and my O2 right now is working properly just means that that sensor's most likely failing as it gets hot. We can definitely see a waveform difference between the two banks. Yeah, I'm okay telling him to put an O2 sensor in this. If it's my car, I'd probably do both upstream O2s. I think what I want to do with this is I want to fix the purge wire, ground it, and then have Danner replace the upstream O2 on Bank 1, and then let the customer take it. Let him drive it. Let him be aware of the possibility of maybe an ignition misfire or something along those lines. Although the random misfire code could absolutely have been when this O2 sensor fails all the way, which will wig out your trims and can definitely give you stuff like that. So I would not want to spend $1,000 on an engine computer for just one bad ground on a purge valve, a very unimportant component. So special thanks to my daughter May. She's got to go. Mom's coming to pick her up. She's got some things that she needs to do, and she was with me for about 3 hours today, so that's pretty cool. Some money in the bank for you. You did a good job.
Thank you.
I think you did a good job. We'll see in the edits on how still your camera work was.
I was good. I was watching the camera and I think I was pretty good.
You think?
Yes.
Well, she's confident. That's a good thing. And what else, May? Thanks for being here with me. I enjoy your company.
Yeah, I love filming.
I know, I like having you. Hopefully we'll get our camera situation worked out for you guys. I apologize for any audio changes, and yeah, we really fought ourselves with the camera without having Caleb here. But I'm not done with this. I'm just saying bye to May. Like I said, we're going to run a ground wire to that purge valve. I'm going to have Danner change the oxygen sensor and then let the customer take it. I think that's the approach we're going to go. So we'll talk to Danner and we'll fill you guys in here in a minute. Just running a ground wire. All right. So we're going after the blue and brown. You definitely wouldn't want to go after the blue-white wire in this application, because then you definitely cook the driver in the computer. It's a power side switch circuit. I mean, it needs a computer anyway, but all right, let's do that bidirectional test again. We should hear that guy clicking now. Thanks, Danner. I needed another song stuck in my head. All right, guys. So our codes. Let's clear this. It made me cycle the key for this code to go away. Okay, code's gone. I want to do this functional test. It'd be nice if it gave me a key on engine off one, but I don't see a purge valve in this list. Some of you might be looking at it and be yelling at me on which one it is. I do not think it's the VLP solenoid. LC solenoid, see, I just don't know. I don't want to guess. We'll have to go back to the running test. And what I want to do for you guys is get you both an amperage reading and a voltage reading, control waveform at the same time. Just to satisfy the curiosity of whether or not amperage was too high and cook that ground. Remember that all of my current flow is going to be traveling. It'll be being pulsed in this way, the same wire that my yellow test lead's connected to, the blue-white. So the computer's going to pulse power this way, and then it gets grounded through my external ground that I built. And so we will just clip over that ground, and that should give us an accurate reading of amperage. Let me set up my scope first before we run the test. So volts DC for channel 1. Channel 2 is going to be my low amp 20, and we'll put that on like a 1 amp scale. 1 amp scales are pretty noisy on these. So, I don't know, we could filter that. I may turn that filter off here. Let's see what this looks like. I'm going to start the car. And go scanner. Purge vapors. We should hear this click. I'm gonna have to get the camera close. Well, we just stalled the engine out. The reason that happened is this thing has not been purging for a long time, and this canister's full of vapor, and I just flooded the engine out. That's why it stalled. That little bit of a long crank time also says that we flooded it. Let's see if I can do a pulsed one rather than a full flow one. So I can't. It's just normal flow and block. It won't let me control the duty cycle. That kind of stinks. It would be better off for you guys for a visual on using the graphing meter. Change this to 20. Channel 2 will be my low amp 20. In the 1 amp mode, 20-second screen. Let's flow this again. It's going to stall. And we can show you that surge. Let's pause that. Those are your control voltage signals. Completely normal. I have my time base set way too long. Peak amperage, the green trace, this yellow trace is kind of in my way here. That green trace that you're looking at, that is 0.68. 0.68 of an amp. So that is 680 milliamps. I have no problem with that for peak amperage. for this solenoid. So around 500 milliamps average, 550 milliamps average of a control signal. Not a problem at all. So over amperage definitely did not cook the computer ground for this circuit. If you need some help in identifying a power side switch circuit and which one the ground wire is, I definitely have some lectures on that. It's in my chapter 3 material where I talk about this procedure. And now that I have a ground, let me just show you that one more time so we're clear. All right, power side switch circuit. This is chapter 3 material if you need additional help with this. I'm just gonna go to my digital meter just to keep this simple. And first thing that you would do when checking any output is to check the wires with the key on. So that one is reading 0 volts. This one is reading 0 volts. What that suggests to us right off the bat is this is a power side switch circuit that is not being turned on right now. If it's being turned on, we're going to see 12 on one side, 0 on the other. This is a pulsed component. I don't want to get lost in that. The circuit is off right now, 0, 0 on a power side switch. So which one's the control wire, which one's the ground wire? Well, it's as simple as taking a test light. We're going to put this to battery positive. And when I find a ground, my test light's going to light. Okay? Test light's grounded. The end of it connected to battery positive. Next step, unplug the computer. Unplug the solenoid. And then check both wires. Again, we can do this unplugged too. Same thing with voltage. Sometimes there'll be a bias. And, you know, with our ground being external, we're not going to have that. But that can be a test you can do. But then the other one would just simply be to touch the pins. Again, not spreading these terminals. Test light is not lighting on that one. And the test light is lighting on that one. Control wire. The one that's not lit. The constant ground. The one that is. So now I know for sure it's a power side switch circuit with a constant ground, and the side that's not lighting is the control wire. Basic stuff, man. Basic. That's my control wire. That is my ground. So why is the computer ground that wire? Why not run that wire straight to ground? Why does it go to the computer? Well, what I've said in the past is it's for circuit monitoring. Computer's going to monitor that circuit, maybe for current flow. In this case, it would have to be current flow because it's not going to be voltage. You're on a ground. It's a constant ground. You will see these power side switch circuits have constant grounds at the computer. Not all, but most. The only one I'm thinking of that is not that way is a GDI fuel injector, where we're switching both the power and ground of the fuel injector. And so those are unique. But every other application where I've seen a power side switch circuit that both wires go to the computer, the one wire is a constant ground and the other wire is a switched power. So why is it done that way? I've always said circuit monitoring. In this case, the ground circuit's not being monitored, at least not yet. I can make that code go away with this jumper wire. Is it possible that under a certain drive cycle that the computer may do a separate test on this solenoid and then we end up with some different code? I suppose it's possible. Would love to hear your thoughts on why we run this ground wire to the computer if it's not being monitored. If it's not being monitored, what's the point? Why not just ground it to the block? I don't know. Noise? I don't know. In any case, this is making this light stay off, so that'll at least let us have this customer take the car and drive it. We're going to change the one upstream O2 that looked a little wonky on our test drive. It's good enough for me. We're changing that 102 and then letting the customer drive it the way it is, and then they can tell us how the car feels before we spend the $1,000 on an engine computer. I just think that that's the way to go on this one. If this ends up working out and working fine, I'm not going to change the computer. If this was my car, I'd leave it the same way. I think that's the best approach here. I'm sorry that there's nothing else I'm able to show you as far as the misfire goes because it's not there. My suspicions are maybe that the O2, when it finally flat lines, because we had a circuit high code, which means a flat line signal, that we could certainly have mixture problems and we could have misfiring from that. And so that's kind of what I'm putting those together with. In any case, we're spending like $100 compared to $1,500 that the dealer wanted in an approach that I think is better than putting a computer in this, which it needs. They were right. It needs a computer and an O2 and then a throttle body clean. $1,500 plus tax, when it might just be a faulty O2 that caused the misfire stuff, and then we can get away with this driver bypass repair. I realize this is not the correct repair. It shouldn't be done this way, and so the dealer is not going to offer this kind of repair. But for us, with some unknowns, this is definitely the way we're going, and I hope you guys learned something from it. I know it's more open-ended than I would like it to be, but there were certainly some things on power side switch circuits in here, how they operate, how they're controlled, that are super valuable, and so we'll bring this to you as it is. So thank you guys for joining us, and I think I covered everything. I'm missing cameraman Caleb. I'm using my small camera that May was holding for the end of this. The audio sucks, the video sucks, but this is how I used to film by myself. Sometimes I miss the simplicity of that. I'll catch you guys next time.